You've seen the buzz around large language models, right? LLMs. They feel kind of magical sometimes.
They really do. You type something in, and boom, this amazing response comes back.
Like it just gets you.
But let's be real. Just as often, maybe more often, it's, well, not quite that.
Yeah, the output can be generic or flat out wrong or just miss the mark completely. It's unpredictable.
And super frustrating when that happens.
Totally.
Yeah.
But maybe that's not the AI's fault entirely. Maybe it's how we're talking to it.
Exactly. There's this whole field emerging, this art and science called prompt engineering.
Right. Crafting the input, the prompt, to get the output you actually want.
Precisely. And for this deep dive, we've grabbed one really detailed source document all about prompt engineering. We're going to break down its key ideas for you.
So our mission here, give you a solid handle on what prompt engineering is, what levers you can actually pull, like configuration.
Yeah, settings.
The techniques people are using.
Yeah.
And the best practices so you can turn that magic feeling into something, more reliable.
Make it a tool you can actually depend on.
Consider this your shortcut to getting up to speed on this really crucial skill.
Okay, so what is prompt engineering? What are we actually doing?
Yeah, fundamentally.
At its core, it's the process of designing, well, high-quality text inputs, prompts, to steer these LLMs. You have to remember, these models are basically prediction engines.
Predicting the next word.
Exactly. They look at your text, predict the most likely next word, then the next, based on just tons and tons of data they were trained on.
So our prompt is like setting the stage, trying to get it to predict the right sequence of words for what we need.
That's a fantastic way to think about it. And the cool thing is, anyone can write a prompt. You don't need to be a data scientist.
Right.
But writing an effective prompt, one that gets you good results consistently, that takes a bit more, it's iterative.
Iterative, meaning trial and error.
Trial and error refinement. And success depends on so much. The specific model you're using. It's training data, the actual words you choose, how you structure the prompt, the context you give it, and yes, those configurations we mentioned.
And if you don't nail those, you get, well, the garbage output.
You get the ambiguous, inaccurate stuff. Yeah. Our source digs into prompting models like Gemini, often through APIs or platforms like Vertex AI.
Because that gives you access to those settings.
Exactly. That access is key to unlocking some of these deeper configuration controls.
Okay, so what kind of tasks can good prompting help with? Is it just Q&A?
Oh, it's way broader than that. The source lists a whole bunch. Summarizing long texts, pulling out specific bits of information, answering questions, classifying text, like, is this review positive or negative?
Sentiment analysis, okay.
Yeah. Translating languages, even translating code from one language to another.
Yeah.
Generating new text, like blog posts or email.
Code.
Or code, definitely. Debugging code someone else wrote, or even code the AI wrote. And handling complex reasoning tasks. Basically, if you can describe it in words, prompting can probably help.
Wow, okay. That's a huge range. Now, configurations. You said it's not just the words.
Nope. Tuning the model settings is a big part of effective prompting, especially with that API access.
Like controlling how much text it spits out. Output length.
That's a basic but important one. Output length. It just puts a cap on the number of tokens, think words, or parts of words the model generates.
Why limit it?
Well, more tokens means more compute time, slower answers, higher costs. Plus, the source makes a good point. Limiting length doesn't change the style, it just cuts it off.
Oh, okay. So it will suddenly become brief. It'll just stop mid-sentence if it hits the limit.
Potentially, yeah. Useful for cost control or making sure output fits, say, a database field. And it's critical for some advanced techniques like React, which we might get to later.
Okay, that's the amount of output. What about the kind of output, like creative versus factual?
Right, that's where sampling controls come in. Things like temperature, top K, and top P. This is how the model chooses the next word from all the possibilities it's considered.
Probabilities, right.
Exactly. It calculates a probability for every possible next token. These settings tweak how it picks from that list.
Temperature. Sounds like it adds randomness.
That's the core idea. Temperature controls randomness. Low temp, like 0, is called greedy decoding. It just picks the single highest probability word every time. Very predictable.
Good for facts.
Usually, yeah. Deterministic, factual, but maybe a bit boring or repetitive sometimes. As you dial the temperature up, it starts giving lower probability words a chance.
So more variety, more creativity.
Exactly. More randomness, diversity, maybe even surprising connections. If you want a poem, crank it up. If you want a factual summary, keep it low.
Okay, and top K and top P, what do they do?
They're like Filter is applied before temperature sampling.
Yeah.
Top K says, only consider the top K most likely next words. So if K is 10, it ignores everything except the 10 words with the highest probability.
So lower K means more restricted, maybe more focused.
Right. Higher K opens it up more. K1 is the same as that greedy decoding, temperature 0.
Got it. And top P?
Top P, or nucleus sampling, filters differently. It looks at the probability list and keeps adding words, starting with the most likely, until their combined probability reaches P.
Ah, so P is like a probability budget.
Sort of. P0 is greedy again, only the top word. P1 considers everything. Lower P is more restrictive. Higher P is more expansive. Similar to top K, but based on cumulative probability.
Okay, so if I have access to all three, how do they interact? It sounds complicated.
The source explains it as a sequence. First, the model finds the words that meet both the top K and top P criteria. That creates a filtered pool.
Okay, smaller list.
Then temperature is used to sample from that filtered list. If you only have one filter, say top K, it uses that. If you don't have temperature, it just picks randomly from the filtered list.
So filters narrow the options, temperature picks from the narrowed list.
Got it.
Any starting points, like rules of thumb?
Yeah, the source gives some helpful benchmarks. For good balance, maybe some creativity, but still coherent. Try temp.2, top P 0.95, top K 30. Want maximum creativity. Brainstorming, fiction. Maybe temp.9, top PB 0.99, top K 40.
Higher numbers across the board.
Generally, yeah. And for strictly factual, less creative stuff, drop down. Temp.1, top P is 0.9, top K 20.
And the really key point.
If there's one right answer math, classification with fixed labels always start with temperature 0. You don't want randomness messing that up.
Makes total sense. And I guess the downside of higher temp or wider filters is it might just ramble, go off topic.
Absolutely. More freedom equals more potential to drift. And the source mentions a common bug related to this, the repetition loop.
Ugh, I've seen that, where it just says the same thing over and over.
Yeah, that can happen when these settings are pushed to extremes. Adjusting temp, top K, or top P is often how you fix it.
Okay, cool. That covers the behind-the-scenes dials. Now, let's dive into the prompt text itself. What techniques work best?
Right, this is where we get into specific prompting strategies, different ways to structure your input.
What's the most basic? Just ask the question.
Pretty much. That's general prompting, also called zero shot. Just the task description and maybe the input text. No examples.
Like classify this review, text, sentiment.
Exactly. Just the instruction and the data. The source suggests low temperature for this, but it notes for complex stuff, like a review saying something is disturbing but a masterpiece. Zero shot might struggle with that nuance.
Okay, so if zero shot isn't cutting it.
You give it examples. That's one shot or few shot prompting. This is probably one of the most powerful techniques.
One example is one shot, multiple is few shot.
Yep. You show the model exactly what you want. Input, desired output.
Like giving it a template.
Precisely. It teaches the model the format, the style, the pattern you're after. For few shot, the source recommends starting with, say, 3 to 5 examples.
But you could use more.
You could, depending on the task. The model limits its context window and how much variety you need to demonstrate. The key is using good examples. Relevant, diverse, high quality, maybe even some edge cases.
The pizza order example in the source was great for this. Show it a couple of orders turned into JSON.
And then give it a new order and bam, it outputs JSON. It learns the structure instantly. Super useful for machine-readable output.
Okay, examples are powerful. What about these other techniques? System, contextual, and role prompting. How do they fit?
Think of them as different ways to set the scene or guide the model's overall behavior. They often work together.
So, system prompting first.
System prompting sets the stage at a high level. The model's core identity, its fundamental purpose, or overarching rules, usually put right at the start or in a dedicated system field if the tool has one.
Like you are a helpful assistant.
Yeah, or like in the movie review example, only return the label in uppercase. A system prompt can enforce that rule even with higher temperature. It's also perfect for instructing structured output like JSON.
Ah, right, the JSON movie review example. Why is JSON so good here?
The source highlights several benefits. It enforces consistency, focuses the model on just the data fields you want, limits hallucination, making stuff up, and it captures data types and relationships. Plus, system prompts are key for safety rules, like do not generate harmful content.
Okay, that's the big picture. What's contextual prompting?
Contextual prompting is about the immediate situation, providing task-specific background info relevant right now. It's more dynamic.
Like the chat history or background documents.
Exactly, giving it the context it needs for the specific request. The retro arcade blog example showed this, telling it the context is a blog about 80s arcade games keeps the suggestions on point.
And role prompting. That sounds fun.
It can be. Role prompting assigns the model a specific persona or identity. Act as a pirate. You're a formal historian. Respond like a sarcastic teenager. It frames the output style, voice, and assumed expertise.
Like the travel guide example. Tell it to be a travel guide.
And it adopts that helpful, informative tone. Change the role to teacher, you get a different response. The source even shows a humorous Manhattan travel guide by combining role and style.
And you could layer these. System for safety, context for the topic, role for the voice.
Absolutely. They complement each other. System sets the guardrails. Context provides the facts. Role provides the personality.
Okay, that makes sense. Now, step back prompting. That name is interesting. What's that about?
It's a really clever technique for boosting reasoning. The idea is before you ask the hard, specific question, you first ask a more general, related question, get the answer to that, and then feed that answer into the prompt for your original specific question.
So it steps back to see the bigger picture before drilling down.
Exactly. That's a perfect way to put it. It encourages the model to access broader knowledge, more fundamental concepts that the narrow prompt might not trigger on its own. Often leads to better, more insightful answers.
The video game example from the source illustrated this well, didn't it?
It really did. Asking directly for an FPS storyline gave something okay but generic.
The urban ambush thing.
Right. But first asking, list 5 key settings from popular FPS games. The step back brought up richer ideas like underwater research facility. Then, using that setting as context for the original storyline prompt, suddenly you get a much more detailed, creative scenario in this underwater lab. That initial abstraction made a huge difference.
That's smart. It primes the pump almost. Okay, another reasoning technique. Chain of thought. COTI.
COTI is a big one, especially for anything requiring multiple steps like math problems or complex logical reasoning where LLMs often stumble.
How does it work?
You simply tell the model to think step by step or show its reasoning before giving the final answer.
Like showing your work in math class.
Exactly like that. The source had that age problem. When I was 3, my partner was 3x my age. Now I'm 20. How old is my partner?
And it got it wrong initially. Said 63.
Yep. But just adding, let's think step by step, made it output the reasoning. Okay, when you were 3, partner was 3339. Age difference is 936 years. Now you're 20, partner is 20 plus 6, 26. Correct answer.
Wow. Just adding that simple phrase changes everything. What are the upsides?
Well, it's super effective for how little effort it takes. Plus, you get interpretability, you see how it got the answer, which helps you trust it or debug it. The source says it also makes results more robust across different models.
Downside.
More tokens. Generating all those steps costs more computation.
Can you combine QAM with the few-shot examples we talked about?
You can. That's few-shot CA. You provide examples that include not just the input-output, but the input, the reasoning steps, and the output. Good if you need a very specific reasoning format. The brother-partner age example showed this giving one solved problem with steps first.
Okay. Next up, self-consistency. Sounds related to QT.
It builds directly on QTO.
Yeah.
Self-consistency aims for the most reliable answer when there might be multiple valid ways to reason through a problem. Instead of just one QT run, you run the prompt multiple times, maybe with slightly higher temperature to get different reasoning paths.
Okay.
And then you look at the final answer from each run and pick the one that appears most often. Majority rules.
Ah, like polling multiple experts.
Exactly. It gives you more confidence in the result. The email classification example showed this. Maybe one path says important, another says not important. Taking the majority vote boosts consistency.
The cost must be higher though, right?
Yeah.
Running it multiple times.
Significantly higher, yes. That's the trade-off. Accuracy versus cost.
Got it. And tree of thoughts, briefly.
TOTI is like COTI on steroids. Instead of one linear chain, it explores multiple reasoning paths at the same time, like branches of a tree, evaluating them as it goes, for really complex problems where you need to explore different avenues.
Okay, complex stuff. And the last technique mentioned was react.
React, reason, and act. This one's really cool because it tries to mimic how we solve problems. We think, then we do something, then we see what happened, then we think again.
Think, act, observe.
Exactly. The LLM reasons about what it needs, reason, decides to use an external tool like a search engine or calculator, act, gets the result back, observe, and then uses that observation to figure out the next step, reason again.
So the LLM can decide, I need to Google that.
Precisely. The Metallica Kids example was perfect. The LLM thinks, needs number of members, who are they, how many kids each. It then acts, searches for James Hetfield's kids, observes 3 kids, thinks, okay, 1 down, acts, searches for the next member, and so on until it can sum them up.
That's pretty advanced. Requires more setup, yeah. Connecting tools.
Definitely. Implementing React involves coding to manage calling the tools, getting results back, feeding them into the next thought step. It's more involved.
The source also touched on automatic prompt engineering, using AI to write prompts.
Yeah, basically using one LLM to generate variations of prompts for another LLM to execute. Then you evaluate which generated prompts worked best, like asking an LLM, give me 10 ways a customer might order a t-shirt. It helps automate finding good prompt phrasings.
Okay, that covers a ton of techniques. Let's switch focus slightly to a really practical area, using LLMs for coding.
Yes, huge potential here for speeding things up or getting unstuck.
Like writing code from scratch.
Absolutely. Describe what you need. Write a bash script to rename files, like the source example, table 16. It generates the script, often with helpful comments.
But there's a big warning here, right?
QGE warning. You have to treat AI-generated code with suspicion. Read it. Test it thoroughly. LLMs don't understand code like humans do. They predict patterns. They can easily generate code that looks plausible but is buggy, insecure, or just plain wrong, often repeating mistakes from their training data.
So test, test, test.
Always. The source even walks through manually testing that generated bash script, creating files, running it, checking results, essential steps.
Okay, besides writing code, what else? Explaining code.
Excellent for that. Paste in some code you don't understand, ask, what does this do? The example shows asking it to explain the bash script it just wrote, table 17, and it breaks it down line by line. Really useful for learning or tackling legacy code.
Translating code between languages, like Bash to Python.
Yep, another strong suit. The source shows it translating that bash script to Python, table 18, correctly using Python's O's and shootil modules. And a good practical tip, ask for markdown formatting for code, especially in tools like Vertex AI Studio, to keep indentation right.
Crucial for Python. What about debugging? The bane of every programmer's existence.
This is where it can feel like magic sometimes. You give the LLM your broken code and the error message you're getting.
Like the broken Python script example.
Exactly. Snippet 3 had the code with 2 uppercase. Snippet 4 had the name error. You feed both to the LLM, table 19.
And it just finds the bug.
Instantly. It says, hey, to uppercase isn't a thing in Python, you mean dot upper, and it gives you the corrected line.
Okay, that alone is helpful.
But wait, there's more. In that example, it didn't stop there. It then proactively analyzed the rest of the script and offered several other improvements.
Really? Like what?
It suggested things like keeping the original file extension, handling file names with spaces better, using f-strings for cleaner output, and adding proper error handling with try.accept. And it even provided the fully revised, improved code block.
Wow, that's not just fixing a typo, that's like a mini code review.
Exactly. It's like having a helpful, if sometimes naive, pair programmer on call 247. Incredibly valuable.
Okay, fantastic overview of techniques and the coding application. Let's bring it home. For listeners wanting to get better at this, what are the absolute key best practices from the source?
Right, the actionable advice, how to navigate this iterative process effectively.
And number 1 has to be examples.
Absolutely. The source hammers this home. Providing examples, one shot, few shot, is probably the single most important practice. It's powerful teaching. It gives the model a clear reference point. Massively improves accuracy, style, format, consistency. Think of it as just-in-time training for your specific need.
Okay. Then design with simplicity. Keep prompts clear.
Yes. Concise, unambiguous language. Easy for you to read means easier for the model to interpret. Avoid jargon if possible. Use strong action verbs. Analyze, generate, summarize, list, compare. The source's before-after New York Guide prompt showed how simplifying made it much clearer.
Be specific about the output you want. Don't be vague.
Crucial. Vague prompt, vague output. Specify the format, JSON, list, paragraphs, the length, the tone, the exact information needed. The blog post example nailed this. Write a blog post is weak. Write a 3-paragraph blog post, informative but engaging, on the top 5 consoles is much stronger.
Instructions over constraints. Tell it what to do, not what not to do.
This is an interesting one. Research suggests models follow positive instructions, return only the city name. Better than negative constraints, do not include the state. Instructions guide, constraints limit. Prioritize instructions, use constraints mainly for safety or strict formatting needs. The blog post example again. Only discuss console, company, year, sales, works better than don't list games.
Control the max token length, either in settings or in the prompt itself.
Right. Practical tip, set it in the API config, or just say in 50 words or less, or write a tweet in the prompt text.
Use variables. Why is that important?
If you're building anything on top of prompts, like an application, variables are essential. Use placeholders like city or product name like table 20. This makes your core prompt reusable. You just swap the variable values. Much cleaner code.
And then the big one.
Yeah.
You just have to experiment.
100%. There's no substitute. Prompt engineering is empirical. You have to try things out.
Like what specifically?
Experiment with phrasing. Ask as a question, a statement, an instruction, like the Sega Dreamcast example. Experiment with output formats. JSON, XML, Markdown lists especially structured formats for non-creative tasks.
Even though JSON can get truncated.
Yeah, it's a risk, uses more tokens, but often worth it for consistency. And there are tools like JSON repair libraries that can sometimes fix broken, truncated JSON. The benefits of structured data are often huge.
What about schemas? Using JSON schema for input.
That's another advanced technique for experimenting. If you have complex input data, providing a schema, like the product example, snippets 56, acts like a blueprint for the model. It helps it understand the structure and focus on the important parts of your input, especially useful for extraction from large structured texts.
And experiment with different models.
Absolutely. Models change, new ones come out, a prompt that works great today might need tweaking tomorrow, or a new model might handle it better. Test across models and versions, and talk to other prompt engineers. Share what works, what doesn't. Use tools that help version and save your prompts.
Any last tips for chain of thought specifically?
Just to repeat, make sure the final answer comes after the reasoning steps. And for reasoning tasks, default to temperature 0. You want logic, not randomness.
Okay, and the final, maybe most crucial, best practice.
Document your attempts. Seriously, it feels like extra work, but it's vital. Keep track of the prompt, the settings, temp, top K, top P, the model version, the output you got, whether it actually worked, result, and any notes. Feedback. The source suggests a table format, table 21.
Why is this so important?
Because it's how you learn. It helps you debug, reuse successful prompts, understand why things failed, track improvements when models update. You can't iterate effectively if you don't remember what you tried. Save your prompts, link them to your notes.
So it's really not about finding one magic prompt and calling it a day.
Not at all. It's fundamentally iterative. Craft, test, analyze, document, refine, repeat. It's a continuous cycle of improvement.
Wow. Okay, that was a deep dive into that source. We went from the basics of what prompt engineering even is.
Right, and why it's needed.
Through configurations like temperature, top K, top P.
Sampling strategies.
Then all those techniques. Zero shot, few shot, system, context, role prompting.
And the reasoning methods. Step back, COT, self-consistency, even react, and tree of thoughts.
Plus the whole section on coding writing, explaining, translating, debugging code with AI help.
And wrapping it all up with those really concrete best practices. Use examples, be simple, be specific, use instructions, control length, use variables.
And above all, experiment and document everything.
It really lays out a roadmap.
It does. With these ideas from the source, you, the listener, should feel much better equipped to actually work with these LLMs effectively. It's about moving past just hoping for magic.
And towards having actual tools and techniques you can use deliberately to get the results you need.
Whether that's classifying text, writing creatively, automating some task, or getting help with tricky code.
It's about actively guiding the AI, not just tossing words at it.
Exactly. So the source material really emphasized that iterative naturecraft, test, refine. Our final thought for you is, how will you take that idea of continuous experimentation and documentation into your own interactions with AI? What new things might you unlock by constantly trying things out and learning from the results? Definitely something to chew on as you start applying these powerful techniques.